WOW TV. My name is Angel and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today you're going to learn about Sir Isaac Newton and his first law of motion. Are you ready to get started? Let's go! Physicists are scientists that study matter, all of the stuff in the universe and how that stuff moves. Sir Isaac Newton is one of the most famous physicists of all time. He is known for explaining gravity. He is also famous for studying and teaching about how stuff moves. Those teachings are known as Newton's 3 laws of motion. Sir Isaac Newton is considered to be one of the most famous scientists of all time. But that almost didn't happen. He was born in England in 1643, and his mother wanted him to be a farmer, and even took him out of school to make sure that happened. Well, he wasn't very good at farming and was soon allowed to go back to school. He became a scientific leader and even created new areas of study in math and science. People who knew him agreed that he was a genius, but he was also pretty difficult to work with. Newton was a math and science professor at Cambridge University in England. His discoveries are things that you've probably used or heard about already. Let's talk about one. Let's talk about gravity. Newton is the first scientist to discover gravity, although it's always been there. Gravity is the force that pulls an object toward the Earth or another object. A big object like a planet will have a lot of gravity. Newton realized that gravity explains why planets and stars move the way they do and why things fall down on Earth. Legend says that he came up with this theory after he saw an apple fall from a tree. He wondered why it fell straight down instead of in another direction. He realized that a force must be causing it to fall downward. As Newton looked for ways to prove his ideas, he developed a new form of math that is studied in high school. It's called calculus. You'll probably study it one day too. Have you ever used a telescope to look up into the sky? This is also one of Newton's inventions. Newton created a reflecting telescope that used mirrors to reflect light, like the light from stars and planets, to make them bigger through the telescope. Almost all telescopes today still use this technology. Most importantly during his work, Newton came up with the 3 basic ideas that are applied to the understanding of motion. Other scientists have studied, tested, and verified these ideas so many times over the years that now we simply call them Newton's 3 laws of motion. Today we're going to look at Newton's first law of motion. It's called inertia. It describes how a stationary object begins to move or how the motion of an object changes. Let's give a definition to Newton's first law of motion. A still object will stay still unless a force pushes or pulls it. A moving object will stay moving unless a force pushes or pulls it. Or, stated another way, an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same direction and speed. This is called the law of inertia. What does this mean? Well, this means that there is a natural tendency of objects to keep on doing what they're doing. All objects resist changes in their state of motion, and in the absence of a force, an object in motion will maintain that state of motion. Think of it this way. Imagine a basketball sitting on a cart. When the cart starts rolling, inertia, an object's resistance to change, actually causes the ball to move backwards when the cart first begins going forwards, as it is resisting that forward motion. When the cart stops, the ball will continue moving because it is resisting the stopping force. Gravity and friction are forces that constantly push and pull the stuff on Earth. So, when we roll a ball, it slowly comes to a stop. On the moon, where there is less gravity and friction, stuff floats and keeps floating. Let's get you ready for your first activity. Let me show you how to set up your materials. You'll need a partner for this. Place an index card or a playing card on top of an empty cup. Place a coin or a stack of coins on the card. Have your partner hold on to the cup for stability and flick the card with your finger. Continue this until the card is moved out from under the coins and the coins drop into the cup. Teachers, please pass out the materials, and then when everyone is finished, please collect them again. I'll wait while you take turns completing this. Good job. Did you get it to work? Now, let's talk about what happened. This activity can be explained by inertia, the tendency of an object to resist a change in motion or rest. The coins, which were at rest, resisted the forward motion of the index card and fell into the cup below. Every object that has mass has inertia. The more mass an object has, the more inertia it has. It is a directly proportional relationship. The card's force was not strong enough to influence the mass of the coins, so the coins resisted the change in motion due to the coin's inertia. Remember, according to Newton's first law, an object at rest will stay at rest unless acted upon by another force. In this case, the force caused by the card is too small to cause a noticeable change in the coins. Newton's laws are obviously related to the concept of motion. Why does an object move like it does? How does the object accelerate or decelerate? To understand these things, we need to understand the relationship between force and motion. Forces can cause motion. Okay, let's define force. We can think of a force as a push or a pull. Have you ever heard of Aristotle or Galileo? Aristotle is known as one of the great thinkers, philosophers, and teachers from long ago. He studied and taught about logic, was one of the first to study zoology, and helped develop the scientific method. Galileo was the first person to publish what he observed in space through a telescope. He discovered that the Milky Way is made of many stars. He found 4 moons around Jupiter. He discovered sunspots, which are dark areas on the sun. He helped people understand that the sun is at the center of the solar system. Galileo worked more at physics than he did at astronomy. A legend says that he climbed the Leaning Tower of Pisa and dropped cannonballs of different weights to see which would strike the ground first. Even though their weights were not the same, they hit the ground at the same time. Galileo learned that objects fall to the ground at the same rate, unless things like wind resistance change the rate. This went against what Aristotle had taught. Most people ignored Galileo's studies and tests until Isaac Newton proved that Galileo was right. This led to Newton's law of gravity. Based on ideas by Aristotle and Galileo, Sir Isaac Newton's first law of motion explains the exact connection between force and motion. Aristotle taught that a force is required to keep an object in motion. He believed that the greater the force was on a body, the greater the speed of that body. His theory was widely accepted. Aristotle's theory remained largely undisputed for almost 2,000 years, when Galileo came to a different conclusion. Isaac Newton built upon Galileo's ideas. He taught that an object will stay at rest or in motion in a straight line with a constant speed until acted on by a force. The tendency of a body to maintain its position is called inertia. So, Newton's first law is often called the law of inertia. Remembering what you learned in the last activity, let's experiment with inertia again. Let me show you how to set up your materials. Then you'll need a partner or small groups of 3 or 4. Place a hoop on top of an empty bottle. Then place a hex nut on top of the hoop. Using one hand, snatch the hoop away quickly so that the hex nuts will fall into the bottle. See who can get the most hex nuts at once into the bottle. Teachers, please pass out the materials, and then when everyone is finished, please collect them again. I'll wait while you take turns completing this. How did that go? Let's talk about what happened. Why do you think this shows Newton's first law? The activity can be explained by inertia. Every object that has mass has inertia. The more mass an object has, the more inertia it has. It has a directly proportional relationship. The hoop's force is not strong enough to influence the mass of the hex nuts. They resist the change in motion due to their inertia. According to Newton's first law, an object at rest will stay at rest unless acted upon by another force. Let's review a little bit. We've covered 3 important things. Number 1, there is a natural tendency of objects to keep on doing what they're doing. Number 2, all objects resist a change to their state of motion. Number 3, with no unbalanced force, an object in motion will maintain this state of motion. This is the same for an object with no motion. Let's talk about force. We know a force is a push or a pull on an object. And now let's connect force to Newton's first law. If you're not moving and you never start moving, you'll never go anywhere. If you are moving, unless something happens, you will keep moving in that same direction forever. You can see really good examples of this idea when you see videos of astronauts. Have you ever noticed that their tools float? They can just let go of something and it stays in one place. There's no interfering force to cause anything to change. The same is true when they throw something at the camera. The object keeps moving in a straight line. If they threw something when doing a spacewalk, that object would keep moving in the same direction and the same speed forever. The only thing that could change it or stop it would be some other force. Let's define inertia one more time. Inertia is relative to the mass of an object. A car has more inertia than a roller skate. When you're moving in a car, you're obviously moving in the same direction as the car. You're also moving at the same speed as the car. Why do we need seat belts and airbags? Because if the car comes to a sudden stop, you would still be moving in the original direction at the original speed towards the windshield. Inertia also explains why we lean towards the opposite direction as a car or roller coaster moves around a steep curve. If it turns right, you lean towards the left. If it turns left, you lean towards the right, because your body continues to move in the straight line it was moving in before the turn. Let's take one more opportunity to prove what we've learned today. Let me show you how to set up your materials. Stack the blocks in a tower, placing a note card between each block. Since there are several students in your group, face the pull strings in different directions. You can use the same small groups as the last activity. The object of this activity is to attempt to remove the note cards from a tower of wooden blocks without causing enough of a disturbance to the tower's balance to cause it to tumble. Because the cubes want to resist any change in motion, inertia, they will stay in place if the card is pulled out fast enough. Starting at the top, pull out the first card quickly. Pull straight back, not at an angle. Continue removing the cards from top to bottom. Try taking each note card out separately, and once you've done this successfully, you should try again by having everyone in the group pull the cards out at the same time. Can it be done? You'll have to be very precise. Do you want to give yourselves an extra challenge? If you try this again, use paper cups instead of wooden blocks. The paper cups have less mass and therefore less inertia. With less mass and less inertia, there will be less resistance to a change in motion, creating an even greater challenge. Do you think it will be easier or harder to keep the object from flying away when pulled? Teachers, please pass out the materials, and then when everyone is finished, please collect them again. Thanks for joining me, and thanks so much for using this WOW lesson. Please check out more at our website at wpafbstem.com.